In this lecture, we will be designing a lap joint. All this while we have been finding out for a given system of plates connected with bolts, how much design force the system can take. Now in this problem, you are given the design load of 160 kilonewton and you are asked to design the lap joint. There are two plates which are to be connected. One is of 16 mm and the other is 12 mm. The width of both the plates is 120 mm. The design load that we have to design for is 160 kilonewton. The plate grade is Fe410 and we are asked to use bearing type of bolts. Okay, so to solve this, first we need to know what is the dia of the bolt. Let us consider M16 bolts of grade 4.6. So that means the diameter, nominal diameter is 16 mm. The dia of the hole will be 16 plus 2, which is 18 mm. And the ultimate strength of the bolt is 400 Newton per mm square. To find out the strength of the bolt, now since this is a lap joint, we know that Nn is equal to 1 and Ns equals to 0. To find out the nominal strength of a bolt in shear, the formula we use is FUB upon under root of 3 into pi by 4 d square. Okay, so this is Ns and Nn is 1. On substitution, we get 36218 Newton. Therefore, the design shear strength is 36218 upon the partial safety factor, which is 1.25, and we get 28974 Newton. Now let us consider the edge distance. We know that the minimum edge distance has to be 1.5 times the diameter of the hole, which is 27 mm. Similarly, the minimum pitch should be 2.5 times the nominal diameter, which is 16 mm. So this 2.5 into 16 works out to be 40 mm. So this edge distance is small e. Let us round it off to 30 mm. And pitch is small p. Now, KB is the least of these four values. So the minimum of this is 0.4907. Next, we need to calculate the nominal bearing strength. Which is 2.5 times KB dt into FU. Now let us substitute all these values. Nominal diameter is 16, thickness, the minimum thickness is 12, and this is 400 94222 Newton. So the design bearing strength will be the nominal bearing strength divided by the partial safety factor of 1.25, and the value of design bearing strength is 75378 Newton. Design strength is the lesser of shearing strength and bearing strength. Therefore, the design strength of one M16 bolt is 28974 Newton. That is, the design shear strength works out to be lesser, and in terms of kilonewton this will be 28.974 kilonewton. Now we have to transfer 160 kilonewton. So the number of bolts required would be 160 divided by the strength of 1 bolt. So 5.5 bolts are required. We cannot provide 5.5 bolts, so we round it up to 6. Provide 6 bolts, and this is how you're going to provide it. So you have 2 plates, okay. We have 2 plates with us, one 16 mm and one is 12 mm. So let this be 16 mm plate, and this is the 12 mm plate, which are connected by a lap joint. That means in section, when we see this, it will be something like this. Okay, that means they are overlapping on each other. So now we have worked out that there are 6 bolts required. So let us provide the bolts in this fashion. All the details need to be given in the drawing, because this drawing goes to the site. So we've been given that this is 120 mm. Okay, so the thickness is given, the width is given, you are given 6 bolts. So please write here 6 bolts of M16, right? Now the edge distance we had worked out would be 30, the pitch we said is 40, okay. Similarly, here 30, this will keep as 60, and this is 30, okay. And here it could be 30 or anything above 30, so I will keep it as 60 mm. This is the connection detail. We need to find out whether what we have calculated is right. So we are checking the strength of the plate. Strength of plate, which is TDN 0.9 AN FU upon gamma M. So you see at each section there are 2 bolts. So AN would be 120 minus 2 times the diameter of the hole into the thickness, the minimum thickness we consider. 410 is the grade of the plate, okay, and this works out to be 297,562 Newton, which is 297.562 kilonewton. This is greater than 160 kilonewton, which we need to transfer. Therefore, it is safe. So it is not only the capacity of the bolt that we should be calculating, but also the capacity of the plate. So in case the capacity of plate was lesser than 160 kilonewton, this bolts that we have calculated would have been unsafe. Thank you.